This is the question now for the third example. It says a 5 microfarad capacitor is charged so that the potential difference, that's PD, we said this potential difference, if you remember, between its plates is 500 volts. The potential difference between its plates is 800 volts, sorry, 800 volts, 8, not 5, 800 volts. Calculate how long the capacitor can provide an average discharge current of 2 milliamp So it's not a solution. As usual, our data comes first. C is equal to what? 5 microfarads, which is equal to 5 times 10 raised to the power minus 6 farads. We know our voltage potential difference 800 volts, and we know that I is equal to 2 milliampere. When we convert it, we would have 2 times 10 raised to the power minus 3 amps, right? So remember that Q is equals to CV. Do you believe that? Alright, which is equals to what? 5 times 10 minus 6. We'll now multiply by what? 800. So Q now be equal to what? 0.004 or 4 times 10 raised to the power minus 3 coulombs. Alright, that's that. And also Q is equal to what? IT. We were asked to find or determine how long the capacitor can provide an average discharge current of 2 milliamps, right? So what are we now looking for? We're looking for the time, T. Making T the subject will now be Q over what? I. So Q, we've calculated it to be 4 times 10 raised to the power minus 3 all over what? Our average time discharge current was, for the discharge current was what? Was not given, but we're giving the current as 2 milliamp. So 2 times 10 raised to the power minus 3, right? So having done that, you would have 2 seconds. That's our final answer. So I'm just treating 3 examples today, but in our next class we would be moving in more deeper to see how we can solve more examples. We would look at electric flux density in our next class, and we would look at parallel plate capacitors and more. So stay tuned for our next session of class. We would have much to look into. Alright, thank you. Please don't forget to subscribe.